So in this video, we're moving away from absolute value equations and now having inequalities. So the relationship between the left side of the equation and the right side will be greater than, less than, greater than or equal to, less than or equal to. So inequalities. And we're going to see that our solution to these is going to be an interval of values, like many values. This video is just going to focus on when the problem is greater than, and when it's greater than or equal to. So greater than, when you have those. So first I want to do some background. This isn't like the mechanics of the problem, but just why the answers are going to look the way they do. So the first thing I'm going to do is graph this function, absolute value of x plus 2. So the parent function is absolute value, and this plus 2 says to take that and shift it to the left 2 units. So there's the graph. But let's say I'm really trying to solve the inequality. When is absolute value of x plus 2 greater than 4? Let me do this in blue. So when is that greater than 4? So I can think about this as our y values. When is your y values greater than 4? So I'm just going to draw a dashed line here. And this is strictly greater than 4. And now I'm going to highlight where my graph is bigger than 4. And you'll notice there's two sections. There's this part of the graph, and then there's this part of the graph. So the x values that coincides with happens to be from here to negative infinity, and then here to infinity. So what does that look like? This looks like at 2, and this looks like at negative 6. So let's try that. Like, what happens when I plug in, I don't know, negative 8? Negative 8 plus 2, is that greater than 4? This is negative. Oh, it is. Because what happens is, if I have a really, really negative number, when I take the absolute value, it becomes positive 6. So that works. Now let me try like a really big positive number. Let me try like the number, I don't know, actually let me just try 4. That's apparently in the interval that works. If I plug in a 4, oh, and I get the same result, that 6 is greater than 4. So there's actually two different intervals that work here that make the left side bigger than 4. So when you have inequalities, because of the symmetry, it's possible to have two different intervals of values that work. So if I were to write this in interval notation, I can go from x values all the way from negative infinity up to 6, and then from 2 to infinity. Now, 2 exactly won't work because 4 is not bigger than 4. And if it was equal to, I would include it. But I'm actually going to write my answer in interval notation from negative infinity to 6, and then 2 to infinity. Now, when you have two different pieces in interval notation, remember the way you connect them is with a U. It stands for union. It's saying this or this. So it's kind of like mathematical or. It's a mathy way to write or. It's a union symbol. That's why we use a U. So that's the background, why your answers are going to look like this. But let's see the mechanics, like what are the steps you're actually going to do to get these two intervals, because we're not going to do it graphically. So I'll walk you through these 4 examples. Just like with equations, your first step is going to be to isolate the absolute value, which is done here. So isolate the absolute value. So make sure it's absolute value on the left, some symbol, and then a number. Then you're going to set up your two cases. And the way you're going to do that, similar to equations, is that 2x minus 10 can be greater than or equal to 12. You can just solve it just like as if you took away the absolute value. But then to get that possible other interval, is that 2x minus 10 could be less than or equal to negative 12. That's going to give me the other interval. And now I'm going to solve both. So I'm going to add 10. So, oh, you know what? I stopped writing the equal sign. So 2x can be greater than or equal to 22. So x could be greater than or equal to 11. And then if I do this one, add 10, x could be less than or equal to negative 1. Now remember, if you divide by or multiply by a negative, that's when you flip the sign. Now the word that's going to go in between these two little statements is going to be or. So when you have a greater than problem, it's going to be an or. It's going to be this interval or this interval. Now your answers for these are going to come in 3 parts. First, this part, x has to be greater than or equal to 11, or it could be less than or equal to negative 1. And there's lots of numbers that could be greater than or equal to 11 or less than or equal to negative 1. 30, negative 20. Something that wouldn't work would be like numbers in between that, like 0, 5. So this is one version of my answer. Another version you're going to give is a number line. So you're going to actually draw this on a number line. I'm going to do this one in blue. So greater than or equal to 11. Close circle because it's equal to. So numbers greater than 11, like 12, 13, 14. That's why the arrow is going to the right. And then x is less than or equal to negative 1. And that one's there. So the number line is the second way you show it. And then the third way you show it is in interval notation. So negative infinity to negative 1. Oop, I put a parenthesis, but that should be a bracket because we're including that. So you see that's a closed circle that's equal to, so it's going to be a bracket. Union 11 to infinity. And just read your graph from left to right. So negative infinity to negative 1 and pick up again at 11 to infinity. I like the interval notation. Usually like you solve it, that helps you draw the number line, and then the number line helps you get the interval notation. So to summarize, the third step is you solve and then represent the answers. And then represent the solutions those 3 different ways. Okay, let's do example 2. So example 2, the absolute value is not isolated. So my goal is to just get this absolute value of x plus 6 on its own. So I need that 3 to go away, I need that 5 to go away. So I'm going to add 3 first, and the order you do this is really, really important. So you reverse PEMDAS. So you're going to add first, then you're going to divide by 5, not subtract 5 because it's connected by multiplication. I'm going to zoom in here. So I end up with absolute value of x plus 6 is greater than 3. So this is when I would decide this is an OR problem. So this is an OR problem, and I set up my 2 cases. That x plus 6 could be greater than 3, that'll solve it, or x plus 6 could be less than negative 3. So it's a double flip for case 2. I flipped the sign, and I changed the sign of the number, like positive, negative. So let's keep solving this. So x could be greater than negative 3, or x could be less than negative 9. Now I'm going to draw this on a number line. So x being greater than negative 3, open circle at negative 3 to infinity, or x being less than negative 9 would be from negative infinity to negative 9. So my interval notation is negative infinity to negative 9, parenthesis, because it's open circle, strictly greater than, union, to connect, saying it's this or this, negative 3 to infinity. So there's the 3 different representations of my answers. Representation 1, representation 2, representation 3. So there's an infinite amount of solutions, but the solutions are contained within these 2 intervals. So if you tried -7 and plugged it in, it wouldn't work. The left side would not be greater than 3. All right, 2 more. On this one, the absolute value is x divided by 5. That's fine. I'm going to start by dividing by -2. And I included this example because here I am dividing by a negative. So that's going to change this to greater than +10. So now I look at it, it's greater than. It is still an or problem, even though it looked like it was going to be a less than problem. It's still greater, so it's an or. So x over 5 could be greater than 10, or x over 5, let's flip it, double flip, less than -10. So x could be greater than 50. I multiply both sides by 5. Or x could be less than -50. So there's some symmetry here. So less than -50, greater than 50. So everything's good from -infinity to -50. Non-inclusive, pick up again at 50 to infinity. So that example is just there to remind you about flipping the sign here when I divided by a negative. So from here to here, that's step 1, isolate the absolute value. Here's step 2, set up the 2 cases. Solve and get your 3 different representations. Now the last thing you might come across, sorry I'm going quickly, if I make the video too long, YouTube does not take it. The last thing I'm going to do is, like, what if this was a +20, unlike the last example? What if I have greater a -10? So just like with equations, after you isolate, when you have a negative here, mayday, mayday, you have to actually think about it. Think, what could you plug in for x to make the left side, when you take the absolute value, greater than a negative? Now realize this is, no matter what you do, always going to be positive. And you want it to be bigger than -10. So anything is going to work. So I'm not going to solve this. If I did solve it, I would get x is greater than -50, or it could be less than 50. And that's going to include every number on the planet. Like, all numbers are either like greater than -50 or less than -50. That's going to include everything. So my solution is all real numbers. Or you could put it in interval notation, -infinity to infinity. Or say all real numbers. So that's possible. So if you have greater than or equal to a negative, your answer is -infinity to infinity. Anything's going to work. Pick the weirdest thing. Pick pi. Pick whatever you want. It's going to work. So you have to do it a little more intuitively there. Cool. Bye.